And we're live. Amazing. Hi, everyone. It's great to have you join us today for the webinar that we're doing. We're thrilled to have you with us. I'm just going to go ahead and share the slides that we have prepared for you today. My name is Filena. I'm the Partnerships Manager at NitroPack. And I have the pleasure of moderating today's discussion between our speakers. Before I present them, do me a quick favor, drop a hi in the comments and tell us where you're joining from. The chat section will be open the entire time and moderated by several performance experts who will chime in with handy resources for you to explore. I also encourage you to stay with us until the end, as we'll wrap up this event with a Q&A session where our speakers will answer all your INP questions. And speaking of them, I have the pleasure of having with me today Barry Pollard, who is a developer relations engineer at Google, Adam Silverstein, who is a developer relations engineer at Google as well, and Ivail Hristov, who is a CTO and co-founder at NitroPack. Hi, guys. It's great to have you here. Are you excited about today's webinar?
Super.
Hi, everyone. Yep.
Amazing. I think we're going to get to talk about something that's relatively new and hasn't been talked about so much yet. And I think it's quite exciting that we get to lift the curtain. So what are we going to talk about today? Today, we're talking about the future of measuring responsiveness, interaction to next paint. INP is set to replace first input delay, or FID, in 2024. And the things we're about to discuss will help you understand, measure, and identify INP issues better. And last but not least, you'll learn some techniques for optimizing your site's INP score, responsiveness, and overall user experience. So without any further ado, I'd like to welcome up to our virtual stage Adam, who is going to explain the importance of having a responsive website.
Great. Thanks for having me. I think you can go to the next slide. Today we're going to be talking about the importance of responsiveness and specifically about interaction to next paint, which evaluates a web page's responsiveness, namely, how quickly does it give visual feedback when a user interacts with the page? Responsiveness is a critical part of the user's experience on the web, and I think we all know this from having had our own poor experiences. And when you have poor INP or poor interaction experiences on the web, it generally leads to things like rage clicks and cart abandonment and people just not wanting to come back to your website or visit other pages on your site. So we know that intuitively. On the other hand, improving your page responsiveness is going to help you with happy users and notably improved metrics. So we're going to look at a couple of case studies before we dig into what INP actually measures. Yep, so the first one is the Economic Times. This site recognized that they had very poor INP. It was over 1,000 milliseconds, and they had a total blocking time of 3 seconds. So they focused on several areas to improve. They streamlined their main thread tasks. They reduced script evaluations, and they decreased the DOM size. And by doing all that, they were able to reduce their total blocking time to 120 milliseconds and INP down to 250 milliseconds. And as a result of that, they saw these increased numbers that you see here, 50% decrease in bounce rate and a huge uplift in page views directly tied to those improvements. And go to the next slide. And just one more example, Redbus, which is like a ticketing booking site in India. At first, they thought they actually had good INP when they measured it in the lab, but when they looked at the field metrics, they discovered that wasn't the case, which can often be the case in INP. And so they set about improving it. What they discovered was they had some really heavy JavaScript and lengthy API calls going out over the network. So they reduced the size of those calls. They used lazy loading to bring the results in more granularly and sort of reduce the load for each one of those requests. And they were able to reduce their INP significantly. And as a result, saw an uplift in sales directly as a result of that work. So some great examples of how this helps improve your website's performance. So anyway, on to the next topic. I will pass it over to Barry for a deep dive into what INP actually measures.
Hey all, sorry, I pressed the wrong button. I will try to share the right slides here instead of leaving the stage. Right, I'm going to talk about, thanks for that, Adam. I'm going to talk a little bit more about the technical details behind INP and what INP is and give a bit of an introduction to that. Both FID, or first input delay, and the new INP that's looking to replace it, they both seek to measure responsiveness of a website. And by that, we mean, does a website react quickly to users interacting with it? Nearly all sites now pass FID, even on mobile devices. And that would be great if that was a true reflection of how responsive websites are. But the reality is that the web often does have a responsiveness problem. It's not true that 94% of websites have no issues with responsiveness. We've all experienced laggy or even completely hung websites. So the truth is, the FID metric is no longer accurately measuring this. Similar to FID, INP seeks to measure interactions and certain numbers of certain types of those interactions. The interactions that play a part in INP's calculations are clicking with a mouse, tapping on a device with a touchscreen, or typing or pressing on a physical or digital keyboard. Critically, some actions like scrolling or mouse movements are not considered interactions, even though effectively they are on some websites. So that's just something to bear in mind. If you do hover over effects or anything like those are currently not measured by INP. An interaction is actually quite a complex process in the browser, as we show by this diagram. When a user interacts with a web page, clicks a button, the web page may already be busy processing, as you can see in this first bar here. So there may be something else going on already, and there'll be a slight delay before starting work on that particular interaction. Then when that interaction actually is ready to be processed, that may be processed as a series of several different events: pointer up, mouse down, and click. They're all discrete events that may all trigger different bits of code to run. After all these are completed, and the events have been processed, there's usually resulting updates that need to be presented by the user by painting these onto the screen. So this measures what an interaction is. FID, or first input delay, only measures this part shown in red here, and only for the first interaction. Now, the first interaction typically happens as the page is loading or shortly afterwards. That's a very busy time for the browser. And we saw this as a key blocker in the past. So measuring this period was the first step to measuring responsiveness. But as I mentioned, it's no longer really measuring the full issue on the web with responsiveness. Interaction to next paint takes all interactions into account, not just the first one. And it takes the whole length of the interaction rather than just the delay portion. Though an important point to note is that INP does not necessarily measure the full cost of an interaction. Some interactions, think about like uploading a video or doing some other heavy processing, can take a lot of time. And that's just the nature of the thing. And that's absolutely fine as long as we don't block the website during that time. And as long as we provide feedback to the user saying processing ... or some kind of indicator about how far through it is. So as the name suggests, INP measures the time from the interaction, for example, a mouse click, until the browser is next able to update or paint the screen. This is the first opportunity to provide some feedback that the interaction has been registered and is being processed. Displaying some feedback, as I say, for example, processing ... or adding to cart, even if you can't complete the full transaction, is a good thing. Blocking the next paint until we complete all the interaction steps is usually pretty bad for user experience. You can think of INP as primarily being divided into these three sections. There's that input delay, as I talked about earlier, until the interaction actually starts to get processed, and that's what FID measured. Then you've got the processing time of the interaction itself. That's likely code that's under your control, though often it can be also libraries that your code calls and stuff like that may not be directly under your control. And then finally, you get this presentation delay, where you've made your updates to the web page, excuse me, and then usually you're expecting the browser to do something. You've updated the DOM, you've changed your styles, and you're kind of expecting the browser to figure out what that actually means in pixels presented to the screen. INP looks at all interactions on the page, as I said, and measures the longest interaction and reports that as the INP score. There's some nuance with the extreme outliers on very busy pages, but I wouldn't worry too much. Effectively, it's usually the longest interaction. And a good INP score is from 200 milliseconds or less. So you click a button, you expect to see a screen update within 200 milliseconds on desktop and on mobile. To ensure you're hitting this target for most of your users, a good threshold, and the one that we use in the Core Web Vitals, is to measure the 75th percentile page loads segmented across mobile and desktop. That's the exact same measurements we take for LCP and for CLS and currently for FID. So we do also have a second opportunity to ignore some outliers. We want to look at what most of your website users are experiencing and saying, yeah, this is a good experience in general across your website. Because there'll always be some people who have flaky connections or just hit a lump in the road and have a bad interaction when it's, in general, they're all mostly pretty good. All the core Web Vitals are measured in the field. There is some lab-based tools that can be used to test metrics under certain predefined conditions, but really they're best measured they really need to be measured in the field. And for responsiveness, which measures user interactions, it's especially important to measure it in the field, because only in the field can you see all the interactions that users do on our website. And you might be surprised what order people do interactions in, or what interactions are more popular than others. So only with field data can you see those interactions, how they're handled by our sites. And Google provides a number of tools that surface INP, including PageSpeed Insights, which shows the field INP from the Chrome user experience, or CRUX at the top, and then Lighthouse data to help you diagnose and improve those below. Google Search Console also now shows the site's INP data along with the other core Web Vitals. This time it groups it into page types, so it's a slightly different slice of the data and way of looking at it. The CRUX dashboard is another tool that shows a trend of core Web Vitals metrics over the last 12 months, which can be very useful to do. And the Web Vitals JavaScript library allows you to collect your own core Web Vitals field data to analyze it in more depth than you can do with CRUX. And then finally, we have the Web Vitals extension, which shows CRUX core Web Vitals field data and also finds a real up-to-date of core Web Vitals as you interact with the page and how they change when you go through it. And as well as these Google tools, there's many third-party tools that also show you core Web Vitals data, including INP now, some of which are based on the CRUX data and some of which they collect themselves through RUM tools. So what causes slow INP? On this slide, we see some of the common reasons for slow INP. I mean, the primary reason is all just about trying to do too much. Too much JavaScript, too large a DOM, creating a lot of work for the browser anytime it changes, too complex CSS selectors, or not leveraging the web platform, but instead using JavaScript or a heavy JavaScript framework to do the things that the browser can often do more efficiently. Beyond that, there's an opportunity to optimize poorly written code, or changing JavaScript to play nice and yield more often. And say if it is a long-running task and it's just going to take some time, at least interrupt it every so often and give the browser time to react and do those things. Third-party code is all too often a leading cause for all the above reasons, or because we simply load too many of them. And yes, I work for Google, but I include Google third-party code in that too. I mean, as the producer of some of the most popular third-party code out there, we at Google have our own responsibility too to help improve the situation. So don't assume that Google does everything perfectly. We're working with the other teams in Google to try and improve responsiveness of their third-party plugins. I'm going to hand over to Valio on to show some optimization techniques for improving responsiveness.
Hey, thanks, Barry. Let me just continue this one. And this was actually a very nice overview of INP. I gotta say that the image where we have all the three sections nicely labeled and segmented is gotta be one of my favorite images that really gives a nice and easy to understand overview of what INP is trying to measure and how to later read the data and help it debugging. And of course, we are trying to apply optimization and fixing the issue. So now we are going to talk a little bit more about the practicalities and how to go about debugging and solving INP issues. And first, I'd like to start with a little overview of what your process should look like. You should always start with RUM data. As Barry already mentioned, this is the best way and the only way to actually figure out whether you have any issues with INP, and then identify where those issues are, what pages are affected, what elements. Even some tools might give information on what interaction types are causing the INP issues. Only then you can go into looking for the root cause, and once you found that, you should then think about applying fixes or solving the issue in general. And this is true for all of the core vitals and in general when optimizing your website. And also think of this as a never-ending process. It's not like you will do it once and then you can say, okay, I'm done now. This is something that you should always monitor and always go through this cycle when you're keeping your website up to date and making sure that your visitors are having a pleasant experience. So we'd like to give a short demonstration here. And we're going to start with an example of an e-commerce website which has a slight issue with INP on the search bar. So you can see that when you try to interact with the search bar, there is a noticeable delay of anything between 300 and 400 milliseconds. So even though this doesn't sound like much, it's definitely something that can be felt and is even visible here in this recording. So our goal will be to identify what's causing this the issue here, and ideally go below 200 milliseconds of interaction times. So the tools that we'll be using during the process, we're going to rely on the Core Web Vitals extension for Google Chrome. This will give us a nice and easy to read data in our console about our progress and our current state of interaction times. We're also going to use the Chrome DevTools and more specifically the Performance Profiler to pinpoint the issue. And then we're going to use solutions from NitroPack to resolve the issues that we find in our website. So without further ado, we're going to go into the demo session here. Let me just switch to that. All right. So this is our website that we just showed. And as you can see, this is the menu. And right away, we can see that the interactions, we can see the interaction times, and these interaction times are actually provided by the Chrome extension. This is why we needed it. Once you install the Chrome extension, first thing you should do, by the way, is find it here in your extensions list, go into options, and make sure that console logging is enabled, save the settings, then go back to here and refresh the page. So you can have these nice loggings in the console, just like we see here. And our next task will be to figure out what is causing these slow interactions. So now we know that it's from this element. We can now use the Performance Profiler, which can be found in the Performance tab, and record a trace of the event. And what we're going to be looking here is down into the flame chart. We're going to be looking at those tasks that the browser did. So every single bar that you see here represents some sort of task. And the longer the bar, the longer the task. So we're looking to find the longest bars, ideally ones that don't have anything below them. And right away, we can spot this purple one here, which says recalculate style. If we click on it, we'll see how much time it took, and we will also see how much DOM elements were affected. And here in this example, we can easily see that we are probably having an issue with a larger DOM because we're working over about 1,000 elements, or just over 1,000 elements, which is on the high side. And the interaction takes, the task takes roughly 200 milliseconds. But what we also see is that there is another part of this this task which has another arm here, and if you go slightly further down, we can see that there is another recalculate style operation here, which takes 140 milliseconds this time and operates over just about the same number of DOM elements. So first thing that we are going to try is reduce these numbers. So we operate on fewer elements. And there are two easy things that we can do here. And one would be to apply HTML lazy loading, and the other would be to help with HTML rendering. So this is something that we call lazy render in terms of NitroPack. And these techniques are good because they don't require you to change anything in terms of your content or the behavior of your website. They typically can be applied and you over your content, and you preserve all of the content that you currently have and all of the current structure of the website. You can also go about just change the DOM structure, change how your website is built, change your content, but that's arguably not a great idea, because then you will start like having to think of other things that you probably already know what content you want to have on your pages and things like that. So we have another version of this web page where we have the HTML lazy render and the HTML lazy loading applied. So interacting with it, we can see that right now we already have the interactions under 200 milliseconds, but just about 160, 150 milliseconds. And we did get actually an outlier here, and we went, the first interaction went just slightly above 200 milliseconds, which is a great example of why you want to have a nice buffer. So you don't want to aim for having your interactions very close to the 200 milliseconds threshold. Ideally, you want them to be under 100. So you have a nice buffer for just things like that, like occasional hiccups that can lead to slightly higher interaction times. So if we take another performance profile now, we would like to inspect how the situation with the style calculation is here after the optimizations. We can see that what currently took almost 200 milliseconds now takes just about 50 milliseconds and works across 500 elements, which is half the elements and almost 4 times faster. And the second recalculate style task is a similar story here. Again, just about 50 milliseconds of response time and 500 affected elements. So the other thing that we can typically do in those situations in order to reduce the amount of elements that we are working on is think about the complexity of our CSS. Very often there is just a very complex CSS tree, which causes also many elements to be affected by changes like we have here. And if we go back to the original version of the site and we go to the network panel, switch to the CSS tab, we can see that with a quick glance, we can see that this site has almost 4 megabytes of CSS, which is quite a lot. So the one thing that we can quickly test and see how it's going to affect the site is to remove the unused CSS. And this is another operation that is very, very well suited for automating it and having an automated solution. So we have a third version of this same web page where we have added the optimization of removing unused CSS. And if we now try to interact with the website, you can see that this is now much quicker. We are hovering around 130 milliseconds for the same interaction, which gives us a greater buffer. And we can be more certain that or more comfortable that we're not going to go over the 200 milliseconds threshold. And if we also take another performance snapshot, we can now inspect the same operations, and we can see that so the first style recalculation doesn't seem to be affected much, but if we scroll down to the second one, we can see that it takes just about 12 or 10 milliseconds, and it works over only 64 elements where it initially operated over 1,000 elements or even more. So with these three simple steps, we managed to actually solve our issue and go under the 200 milliseconds threshold, which is essentially we achieved this goal. And this is the point where we are now, we should now deploy to our production website and see how these changes fare in the real world. And just to recap, we started with an introduction of anything between 300 to 400 milliseconds. We identified two main issues, large DOM and complex CSS rule set. We applied three simple fixes, removed unused CSS, HTML lazy render, and HTML lazy load. And this gave us the good result of interactions under 200 milliseconds. And in terms of data for WordPress websites, having a large DOM and complex CSS rule set is actually the most common cause of INP issues. So it's very likely that these same techniques will work for you as well. Of course, there can be other problems. There can be, for example, very compute-heavy tasks that are running on your main thread. So for those, there are other ways to improve them and to resolve the issues. Like Barry already mentioned, try to split those tasks into smaller ones, yield more often to the main thread. This will allow the browser to process the user's input and will make it so your site doesn't feel frozen for visitors. Or if the task doesn't need to communicate with the main thread a lot, you can try moving it to a web worker. These are typically great candidates for that. And if some level of access to the DOM is actually required, you can still try to move to web worker and bridge the gap with a library like Partytown. So you can some level of access to the DOM you can still keep that if that's needed, and see if this can solve your issue. And with that, I think we are ready for our Q&A session.
Yes, we are. Great insights, Ivailo. Thank you very much. Adam and Barry, thank you as well. The chat section has been on fire during your presentation, so I'm sure everyone is excited to dive in. So let's transition into the Q&A session. I can see that one person is asking, what do I do if the code causing the issue is not under my control?
I can take that one.
All right, so yeah, that's probably one of the tough ones. So one of the first things that you can do is reach out to the vendor of the problematic code and see if they will be cooperating to fixing the issue. Or you can, again, the third-party code might still be slow because of, for example, it's interacting with your DOM. You might still be affected with the issue of large DOM, or you can again try to load these third parties into a web worker with something like Partytown and see if that helps. Or just if it's an option for you, just look for a replacement which provides just better results.
Yeah, and like just to carry on from that, I think a lot of people think, well, it's not fair. Why am I being penalized for code that isn't my problem or isn't my fault? Well, I'd swing that around and say it's not fair on your users. Why are they being penalized? They're the ones still suffering it. So the Core Web Vitals doesn't care what technology you use. It measures it, and it measures all the same. So if third-party code is causing problems, and as I mentioned during the presentation, it quite often does, if that's causing problems for your users, we report it back. And then, yeah, as Vario talked about there, there's various options. But ultimately, there's an issue there. So we need to decide what to do about that. Do we accept it? Do we try and improve it? Do we reduce the number of third parties on our websites? Do we complain to the third parties? Quite often, third parties are quite responsive when you raise these things to them, but everyone else thinks, oh, someone else will realize this and sort it out. So, and particularly if you're paying for this third party or you're paying a license fee, there's a contract there, and you should push back and say, hey, this is being flagged as a potential issue in my website. What are you guys doing about performance of that?
Yep.
Amazing. To move on to the next question, someone wants to know, what if my interaction is long running, for example, uploading or processing a video? Do I need to complete this within 200 milliseconds?
So I touched on that in the presentation. I don't know if that question came in before then, but no. So it's interaction to next paint. It's not the full length of the interaction. So if you're doing that, the best UX thing is to say processing ... or show a progress bar to show how far it's going through. But if you do nothing and you process that video and the whole web page is blocked, and as they scroll around it's really janky and horrible, then yes, that will cause a problem. But if you sit there and say processing the video, you've uploaded the server's doing something, or there's a web worker doing it on the client themselves, as long as you're not blocking the whole page, then no, it doesn't need to complete. It's not the whole total duration of the interaction. It's the interaction until the next paint. Saying that, if you are doing a lot of work in the browser and you're not uploading it to a background thread, you might present here and say, hey, video being processed. But if it's doing a lot and someone tries to do something else, hit cancel or do something else, and all that processing actually happens on the main thread, then you can affect the next interaction. So this one's fine, it's done its next paint, but the next one then suffers because the browser's too busy. So just doing a paint and offloading it is a good strategy, but it's not going to solve everything, because you will lead to congestion and potential problems in the future. You're kind of offloading the problem to the future.
Thanks, Barry. I think that you're probably one of the best people on the planet to answer that question, so quite lucky there. Then someone else is asking, is INP measured even if the video is not at the top? I assume they mean in the above the fold section.
Yeah, I started talking to someone in the chat there, so sorry, I will let other people speak, I promise, but I'll grab this one because I started talking there. All the core web vitals are measured for the whole page. So if you have an iframe, let's say a YouTube video, and the YouTube video is quite slow, you hit play, it takes ages for the video to start playing, and then you hit pause and it takes ages for the video to start pausing. That will affect your page. So we measure all the interactions across anything that happens on your page, because your users don't realize that's an iframe unless they're web developers like me and they're geeking behind to have a look at the source code. They won't know. So we measure all the core web vitals there. What INP does is it measures any interaction across the lifetime of the page. So I'm not sure if the question is if it's in the above the fold, as we used to say in the old days. So LCP typically only measures when the above the fold content is done, and as soon as you start scrolling, it moves on. INP and CLS measures everything across the whole page lifecycle. So if you scroll to the bottom and there's a widget there and it's really slow to interact, or it's in an iframe, that will still count towards your stuff there. So you do need to be aware of that. And some of those ones, for security reasons, can be more difficult to measure in the field. So if you're seeing a high INP, but there's, you're trying to collect data to see why, and it's not coming through with anything, but there is a iframe widget there, then that's one to keep an eye out for, and try and test that in the browser and see if that's quite small, because your RUM tool may not report back accurately everything for that, because of, as I say, certain web security restrictions, you can't see into iframes and to gather data and so on.
Great, thank you. Next up, we have, how do I identify the interaction causing the slow INP on my website?
Yeah, I also noticed a similar question where someone asked, how did we actually identify that the search bar is causing the INP in our demo? So you do it through RUM data. You collect the data, and it will tell you which pages are slow or are having issues, and ideally, depending on the tool that you're using, you'll be able to see even which element and which interaction is causing the issue. So that's generally the easiest way that you can identify those. You can also go and start clicking around and interacting with your pages, but
yeah, for those people
you can
that don't
never
know,
recreate the situations. Yeah. there are different conditions, and ideally you want to have a nice picture of what the condition is. Is it a mobile device? Is it on a mobile connection? Which page it is, which element it is, things like that.
Yeah, I agree. Ideally, your run tool will say it's on this page and it's clicking on this button, or it's this particular script that's doing that. I will say not a lot of run providers currently provide that level of feedback. So some of them do, some of them don't. We're working with a lot of run providers to ask them to add that sort of thing. Or if you don't have a run solution, it can be more difficult. When you're first starting with INP, doing a trace, performance trace, like Valia did as showed in his presentation, can often catch general problems with the website. But if it's a specific interaction that's slow, then it's more tricky, particularly if the rest of your website is well optimized and you're like, I can't find this interaction. You can click around, you can try and find it, but it's on a well optimized website, if one thing is wrong, it can be very difficult to find it without run data. But yeah, as you're first starting, profiling it and just seeing how much JavaScript you're running or how big your CSS selector or your DOM size is, and those can find general INP issues that are probably going to affect every interaction anyway. So it can be easy at the beginning to find a couple of interactions and go, oh, right, this. And if there's a common cause, then and you can fix it, fantastic. You'll probably see your INP scores drop at that point. But then you get into the specifics that are more tricky to hunt down.
Great, thank you. Then someone has asked a bit of a trickier question, and they want to know, can't I just cheat INP by doing a non-meaningful update before doing the processing?
Well, it depends on your definition of non-meaningful there. But yeah, I don't consider that cheating. We want you to give an update, processing, uploading. Yes, I got your click and I'm doing something with it. Ideally, everything will be done if it's a short thing. So click and suddenly you see your basket go up to 1 item in it or something like that. If you can't, it's not cheating to say, I've done something and I'll still got work to do and I'll get back to you on that. That's entirely what we want people to do, because all too often people just, it takes 3 seconds to add something to a basket for whatever reason, and it blocks the whole thing for those 3 seconds. It's much better to let you get back, do it, and then it takes a couple of seconds to do that. But again, from a UX perspective, people are like, I add to basket, I'm not sure if it's actually added anything. I'll add to basket. Nope, still not sure. Suddenly 3 things are in my basket and I have to go in and remove 2 of them. So you do want to give some feedback there to do it. But if it's not the total interaction, that's not cheating. That's good. I'd say take a little bit of issue with non-meaningful, depending what you mean that. If you're literally just updating a pixel, then not great UX, not the way you want to do it. But at least you're not blocking everything else from happening if they click another button or do something like that. So I don't consider that a cheat. I consider that what we're trying to encourage.
One thing I would add, which you also said before, Barry, is that if you're just delaying a heavy work that will also block the thread, you're just putting off the bad interaction, right? So just showing something and then doing a bunch of heavy work without yielding the thread is not necessarily going to solve the problem. But it is always good to show users that something is happening. That's always a good thing.
Yeah, and actually in that one, that can actually make your investigation trickier, because then you get that input delay I talked about, and you're like, well, I don't know what was going on. We're releasing new APIs to help you figure that out, but it can be, if you click a button and you know that button's slow, you can look at it, you can figure out the code or the reason why it's slow, you can optimize it as we showed there. That's great. If you click a button and you know it's slow, but it wasn't the button's fault, it was something else going on, that's always a little bit trickier, because you have to figure out what was that other thing that wasn't this button that was happening before. And yeah, so it can be to do that. Thanks, Barry, and great name.
Great, thank you. Then we have someone who actually missed some part of where we showed how to identify the search bar as the element with INP issues, and can we explain that again?
I think we covered that in the previous one, but generally your RAM tools will provide that information, and this is how we got it as well. So
okay, great. Then another one, maybe this one is going to be for Vival. How can NitroPack help with INP issues?
So Yeah, the three probably biggest things are like in terms of what people typically experience in WordPress sites are the large DOM and the large and complex CSS rule set. So those three example features that we had are probably something that you want to try, want to give it a try. Generally speaking, there can be other causes, and then some other so there you can use first of all the performance profiler to figure out whether you need those solutions, but overall just start with those three and see how it goes. If you have any questions, feel free to ask us. And yep.
Absolutely. We will be happy to continue the conversation over email or any other place where you like to communicate online. Great. So another question we have is, does JavaScript delay affect INP?
I'm not sure that I understand the question, but
yeah, if it's general slow running JavaScript, then absolutely. And again, it depends if the JavaScript is offloading work or doing something like that. But if it's hogging all the browser's processing power, absolutely, that's what INP is supposed to measure. And as I say, JavaScript is a big part of the problem, but it's not the only part. We can have large numbers of DOMs, complex CSS selectors, other things like that. But yeah, JavaScript is often quite a big part of the problem.
Yeah, and if by delay you're talking about things like timeouts in JavaScript, these are typically not going to be causing issues, depending on how they're used. But yep.
Yeah, I mean, one of the big things that we recommend to solve INP is breaking up your JavaScript using set timeout or some of the newer APIs that Chrome's been releasing there, and chunking it up into little bits. I'll do a little bit, and then I'll allow the browser to have some time to do any updates that it needs, and then I'll do a little bit more, and then I'll allow the browser to have some time. So that's definitely a great way of helping solve INP, rather than I'm going to do this and it's going to take half a second and you can just bloody well wait. Oh, excuse me. Sorry. Yeah, so you do want to break up processes into as many smaller tasks as, well, a number of small tasks as to allow the browser some breathing room.
Yeah, and even if you keep some of those kind of, if we call it them slow JavaScript parts, you can offload those so they're not running on the main thread, and then it's typically not an issue. It can be, but it's typically not an issue. So web workers have been around for a long time now, so try to leverage those, see if you can break those tasks, make those tasks in a web worker, and see how that works. Maybe you don't have to do the complicated refactoring of splitting up a task or thinking of a different way to do things. You might just be able to offload it to a separate thread and have a nice improvement there.
Yeah, I would say that
depending on the task.
Yeah, for certain tasks that works great. So if you used video processing as an example several times, that sort of thing, or image processing or whatever, when you're doing computationally expensive stuff in your web app, or if you're running a spreadsheet type program and there's lots of calculations, absolutely. For most general websites, hopefully you shouldn't need to do that. That's quite a big chunk of re-engineering. If you're opening a menu, I would hope you wouldn't have to offload that to a worker task, because there is a cost to offloading it and then onloading it again, more time rather than processing. So yeah, you shouldn't need to do it for most things, but if there is something that you're doing a big calculation of some tax return calculation or something that's being done in the browser, then those are the great things to offload away from the main thread.
Great, thank you. Quite a comprehensive answer there. Then the next question wants to know, is there a best way to have videos on your page that won't lower INP?
I have one suggestion, which is I think people are talking about like YouTube embeds and things like that, placing that on the page. There's a really great light version of that uses the sort of like facade pattern. So I guess I would say seek out a plugin that lets you embed videos with a facade pattern, where instead of loading the video, it just loads like a thumbnail version of it, and then the user has to click on that to make it become interactive. That sort of delays all of the JavaScript from loading. That's one good technique. People probably have others.
Yep, and if it's for a video that you're self-hosting, for example, I think CDNs are a great option because this can help with like delivering the data quicker. So depending on how you're updating your UI, this can help as well.
Yeah, videos are also kind of specialized. So the YouTubes or the Vimeo and stuff like that, they're usually quite good at delivering the sort of stuff. And saying that, sometimes they put too many features you aren't going to use in there. You just want a simple video and you don't need all the extra bells and whistles. There can be a cost there. So there is a balance, but really hosting performant videos can be a little bit tricky if you don't know it. So if you've got one video on your website of just your, I don't know, your marketing promotional material or something like that, I definitely tend to offload it to someone else who knows how to do it, upload it on YouTube and embed it there, possibly with the light embed if you can find that, because that definitely does save on it.
Yep.
Thank you. Then the next question is, do you know if INP will be added to the Lighthouse extension once it goes live, or will it be proxied by a different metric like FID is currently by TBT?
It will be proxied, but not by a different metric. TBT is also a good way of measuring INP, so we don't have another metric there. So INP depends on an interaction. It's in its name. Same with FID. So what Lighthouse typically does, and there are different ways of running it, but what it typically does is a cold load of the page. It just loads the page and says done without any interactions. So therefore, it wouldn't measure any INP. What TBT does is it measures how much that main thread was being blocked during the time, which is a pretty good indicator, because if someone clicks on something during that time while the page is loading, you're going to get a problem. And it also gives an indicator of how much processing is going on in your web page, be that JavaScript or be it layout and so on. So even later on, you click something, the page changes a little bit, it has to do a lot of processing to do that, then that's going to be a likely problem. There's other modes in Lighthouse, user flows, I think they're called, and so on, where you can in effect run the Lighthouse on a live page while you're changing and interacting with it, and then it will give INP. But in general, for the typical use case of Lighthouse, no, it will have to be proxied the same for the same reasons as FID.
Great, thanks, Barry. The next question we have is, how does lazy load affect INP?
Yeah, I presume this is kind of the more commonly known lazy loading of images or iframes. And like Adam already mentioned, for the facade thing for images can help you like delay the execution of heavy JavaScript, but also the same thing, like if you're trying to load a video or an iframe or lazy load or images, and while they are loading, you try to interact with the website, this is when you can potentially have a problem with INP. And it can be quite hard to debug, actually, when you're later trying to figure out what's causing the issue, because you're likely going to be trying on when the page has already loaded. So applying lazy load will essentially can help, because it can delay those loading of those iframes or those additional scripts or those heavy images that are potentially not currently needed. So this will free up the main thread, and it will allow interactions with the visible elements to be quicker. So let's say you load up a page and you want to click on the menu. That menu, the main thread will be able to process what's needed to open or close the menu, instead of it still loading some videos below the fold or images below the fold. So in that sense, lazy loading can help.
Yeah, and I'm just looking ahead. I see we've got another question on this, so I'll save some of the comments that are there. But yeah, in general, lazy loading, like the load time of a web page is the busiest time. It's trying to load the web page, get everything from the network, download it all, process it all, just to display it. And then after that, it's, kind of puts itself back and goes, okay, I'm done now. Go ahead until interactions happen. So it can be the worst time. That's why we measured first input delay originally, because it's kind of like everyone has to get on the motorway at once, and they can all crash into each other and cause a big pileup. But once you're on the motorway, you usually zooming along, and yes, accidents can happen at some point when you go there. But there's definitely a higher risk in there whenever everyone's trying to come in at once. So offloading as much as you can onto that and lazy loading it is usually a good pattern. Saying that, if we can move on to the next question, because I see it's very related to this.
Yeah, we do have another one about lazy loading. Lazy loading scripts became a common method, especially in WordPress. If heavy scripts are loaded after user interactions, does this possibly slow down INP?
And the answer there is yes. Like I say, it's good to offload stuff for that, but if you have certain scripts where you click a menu and it has to load all the processing script for that and can't do anything until that loads, and it's kind of synchronous almost, then yes, we do see that. And you sometimes notice that yourself. You click a menu, it doesn't open, but then afterwards you can click it open and close really quickly. So it's that first one just took it was glitchy for a second or two, and then after that it was really good. So you got to be careful that lazy loading until after the load and getting out of the way is good, but not doing anything until the user starts interacting can be bad, both from INP and also just from a user experience perspective. It's kind of annoying whenever you do that. So overly lazy loading can also be bad. So you kind of want to wait until the browser's kind of quiet and then say, okay, now let's get the other stuff that we think is commonly going to be interacted with, particularly menus and sign-up forms and that sort of thing. If it is a much more complicated bit of code, then the facade pattern that Adam mentioned earlier is quite good, but just be honest with the user that I'm going to load this now, or starting widget ... and the map loads, or it does something like that. I think that's much more acceptable whenever you're saying this is not loaded, but I'm loading, rather than just it looks like it's there, but it doesn't actually work properly until you click it a few times.
Yep. Definitely there is a balance there. So especially for those initially visible elements, the ideal way would be for not lazy loading scripts that respond to events in those elements and load them early.
Awesome, thank you. Let's try to do one more question before we call it a day. And then we have another one that we can answer via email. I think, Barry, this one is aimed at you, and it's, is Google now taking this metric into account as a ranking factor? I'm assuming that it's part of Core Web Vitals, or if it's relatively new, we devs have time to fix it and scores before it affects an update that takes it into account.
Yeah, I've a lot to say about this. Good question, by the way. So it doesn't officially become a Core Web Vital until March next year. We haven't decided exactly when in March, but you've got until then. I will post a blog in the chat where we announced that. So in theory, that's you've got until then, and we said whenever we launched the Core Web Vitals initiative, we'd give people time whenever we're making major changes like this to get that right. We are preparing it, so all our tooling is including INP now, quite often with a little icon saying, if you hover over it, says pending rather than an actual Core Web Vital minute. As I mentioned, it's available in the Google Search Console graph, and Google Search Console started emailing sites a few weeks ago with INP issues, saying, hey, you've got INP issues, this is up and coming, come and have a look at it. So in one sense, yes, you've got time. in another sense, the reason we measure these things are because they're bad user experiences. So your users aren't going to be happy on February 28th and then unhappy on March 1st because it becomes a core web vital. So this is a real problem with your website. If you're at 201 milliseconds, 202, maybe you're okay, depending on the actual widget is. But if you've got an INP score of 500 milliseconds, that's half a second when your users, on average, are waiting around for something to happen. So you can get real business benefit by optimizing for this now, even if it's not officially a core web vital until March next year. So I would say don't just sit there and go, okay, I'll put my feet up and do it. And then the other reason is it's actually quite a tricky one to optimize for. I mean, sometimes it's easy. You've got a load of plugins, you don't use half of them, you delete them, the ones you don't use, and whoa, everything's great. If you're in that boat, good for you, lucky you. Many people are, when they start looking at it and they realize, oh, actually, it's a bit more complicated. We're going to have to dig into this. We're going to have to figure it out. We're going to have to set up a room solution to be able to track what interactions are slow or what pages are slow, because Crux doesn't give us the details we need. So it can take a little bit while to optimize it for it. So again, you don't want to wait until February 28th and then suddenly realize you've got 3 months worth of work to actually be able to do anything with this. So I definitely encourage people looking at it right now, rather than waiting until it becomes a core web vital. But yes, officially we always give the lead time to make sure that people have time to optimize it and so on.
Great, thank you. And a final question, just to make sure we don't leave just the one question unanswered. Does Googlebot consider scrolling as INP?
So I think that I'll answer that in two things. One, Googlebot doesn't measure INP. So we mentioned it in the last webinar, is INP is measured through real Chrome user experiences. So Googlebot doesn't measure it. Lighthouse doesn't measure it. It's you that's measured. As you're on the NitroPack website, it's sitting there collecting that anonymous data, unless you've opted out, and saying, let's all feed that back. We put them into a big melting pot, and then we sit there and say, on average, your users, or 75% of your users, had this good experience. Whether Googlebot was fast, slow, or Lighthouse is fast, slow, doesn't matter that. It's what your users experienced. So Googlebot doesn't scroll, as far as I know. I don't work on the Googlebot project, but doesn't do any of that sort of stuff. Then again, it doesn't need to because it gets old content. Your users do, so that's why we measure it. But scrolling also isn't part of INP, as I mentioned in the presentation. It's more clicks and so on. But yeah, it's not Googlebot clicking. It's actually your users clicking and whether it was fast for them, which also makes it really fun or tricky because some users have the latest, greatest devices and a fast network connection and always have a good experience. Other users are in a hotel room at the moment with a slightly flaky Wi-Fi that's thankfully held up for most of this webinar so far, and may have older devices, and everything just takes a little bit longer with them because their devices are slower or older. So you're at the mercy of your users. And if you're a tech blog website with and your readers are all on the latest, greatest stuff, you're going to have an easier time passing INP than if you're a general website used by a lot of other people with older devices.
And with that, I think we've answered all our questions, done all the presentations, and covered quite a bit of ground. So just a few final remarks. I just want to assure everyone who tuned in today that you will be getting a recording of the webinar via email tomorrow. And before we call it a day, I just want to remind you that this is only part 2 of our 4-part webinar series. Part number 3 is going to be all about how to master LCP optimization for your website. It's going to go live in about a month's time on October 19th, and we'd love to have you join us again. And if you'd like to carry on the conversation about LCP, INP, Core Web Vitals in general, anything at all, please feel free to connect with us on Twitter, LinkedIn, anywhere you're active, and we'll be happy to chat with you. We hope you found this useful, and thank you everyone for joining.
Thank you.
Thanks all.
Thanks.